Okay, we're going to do another example of finding rates of change using the difference quotient, and in this example our f of x equals 1 over x. First thing we're doing is finding the difference quotient, so we're going to have, remember the difference quotient is f of x plus h minus f of x, and all of that is over h, and once again we're going to plug this entire parentheses here, this entire quantity in for x in the function to find f of x plus h. That's going to be 1 over x plus h minus, and now we're going to plug in what f of x is, which is 1 over x, and all of this is divided by h. Now to simplify this one, in order to eliminate the divide by h, I'm going to multiply the numerator, and if I multiply the numerator by something, I better do it to the denominator as well. I'm going to multiply the numerator by both of these little denominators. These are the, in other words, I'm finding the least common denominator of this two smaller fractions, and that denominator is going to be x times x plus h. Okay, and in the denominator I need to multiply by x times x plus h as well. Okay, now in the numerator I'm going to distribute both of these multiplies to both terms inside the quantity there, and what I'm going to end up with is x times x plus h divided by x plus h minus x times x plus h divided by x, and all of this is over h times x plus h. Okay, now this factor here eliminates and the x's here eliminate, and I'm left with x minus quantity x plus h all over h times, if I distribute the x into the parentheses, x squared plus xh. Okay, in my numerator when I distribute the negative in here, I'm going to get a negative x and a negative h. The x and the negative x will cancel. I'm left with negative h over h times x squared plus xh. And now my h's cancel, and I'm left with negative 1 over x squared plus xh. And that is my difference quotient in this case. Okay, and that's going to look like this. There it is, negative 1 over x squared plus xh. Now I'm asked to find the difference quotient between 1 and 4/10. Okay, and again, remember we're going to plug in x as the beginning of my interval, which in this case is 1, and h is the width of my interval, which in this case is 4/10. Okay, so I'm going to plug the 1 in for x here in for both x's, and the 0.4 or the 4/10 in for h, where the h is. And when I do that, I get negative 1 divided by 1 squared plus, this simplifies to 0.4. Plugging that into my calculator, I get approximately negative 0.7142. Okay, now I'm asked to find the instantaneous rate of change at x equal 1. Again, we're looking for it at x equals 1. For instantaneous rate of change, the width of my interval is equal to 0. So now I'm going to go back up here and plug the 1 in for x again, but now I'm going to plug in 0 for h. And when I do that, I get this, plugging in the 1 for the x and the 0 for h. This clearly eliminates itself because I'm just adding 0, and I end up with negative 1, and that is my instantaneous rate of change at x equals 1.